Hi, in this video I like to show how to model a gear in Onshape. I prepared this table in Google with a couple of formulas and values that can be found on the internet. For me important is that I always can determine the size of the gear, meaning the outside diameter and also the number of teeth. I'm sorry. Based on that, I can get all the other values that are needed for modeling the gear. So let's get started, and I will explain all these things a bit later. First of all, I make a sketch on the front plane. The first thing I do is I draw the all these three diameters: the root, the pitch, and the outside diameter. The outside and pitch diameter I'm going to change to construction lines and give them now the dimension as per my calculations here. The formulas are on the side in case you're interested. So the outside diameter is 5. Zoom in. The pitch diameter is 4.62. And the root diameter 4.23. Just for clarification, I'm not an engineer, and I did not read in very details about gears. For me, it was just important to get enough information in order for me to model gears and to make them fit into my design. So I just want to clarify that up front in case we have some experienced gear engineers. They might find it a bit too simplified, everything, but it works for me and hopefully also for other hobbyists that just need gears to make their parts work. Okay, so I have now all the diameters for my gear. The next thing I'm going to do is to create vertical construction line. So I need that in order to draw this quarter angular circular, which is going to be which I need in order to draw the first quarter of my tooth. But yeah, we see that in a moment. So I draw another line and bring now a dimension here, and that is 3.75. Okay, I make this also a construction line. And then another construction line, this time horizontal, and I draw this, the intersection between this first vertical construction line and the pitch diameter. From here I'm going to another construction line, and this time this line is going to be my the pressure angle. So this is between these two, and this is 20. I read that for gears 20 and 14.5 are the most common used. In this example, obviously I used the 21, but 14.5 I heard is also a very common used value for the pressure angle. Okay, with this completed, I can now start in drawing the quarter angular circle pitch. The first one, I need two. So the first one need to be intersected again here from the pitch diameter. The value is 1.15. Okay. I forgot one thing, but it doesn't matter. I can show it now. The reason I drew this this pressure angle is so I can determine where my base diameter is. You can also there's also a formula to calculate, but I found this way much more simpler. So if you have your line, your pressure angle figured out, the only thing that you need to do in order to determine your base diameter is you draw a circle. I stop it here, construction line. What you have to do now is make it tangent to this line, and this line here is now called the base diameter. So if you look around in internet, yeah, that is what it is. This is going to be the base diameter. So just for a quick overview, I don't want to make it too complicated. This is the root diameter, the base diameter, the pitch diameter, and this is the outside diameter. Okay, now that I have the base diameter, I can draw my second pitch point diameter circle, and I have to do this on the intersection between the first circle and the base diameter, which is here. And I see here with Onshape, you see it, there's a bit offset. So let me cancel it and try it again. It's still in the beta version, so that will be corrected, but I have to do it now with iMeasure. I do it like this. Okay. And it needs to have the same size, so I mark these two then equal, and they should have the same size. So that's fine. I have now all the sketches available I need in order to start with the tooth. I do one tooth and then I can copy it around using the circular pattern tool. Okay, I use this arc tool to outline where the tooth needs to be. So this is from here to here. That's number one. Then from here to here. And now I just want to make sure that these two lines are tangent to each other. Okay. I can then mirror this the first half of the to the other side using, I go out to see it, using this line, which is the quarter angular circular pitch I draw in the beginning. So that is going to be my mirror line. It asks me, this is the mirror line. And then I close using these two. Okay, that's it. That is the sketch. I have now everything in order to complete the sketch, extrude and finalize the gear. So I finish the sketch, extrude as the base, then the tooth, and I make it 1 millimeter in this case. Okay, and now I copy this around using a circular pattern. Axis stars. Okay, now we can see the values on the table. We're using 24 teeth. And the degrees is 15. That's the angular circular pitch. Okay, and that's our gear. We have now a 24 tooth gear or teeth gear, and you see already there would match, the end would match perfectly in this hole. So I'm going to probably create a second video where you have two gears interacting with each other, and also update this table. Once I have it completed, I will make it available for download.